So it's obviously not a real bear trapped in the log, it's the idea of a bear. And my CNC chainsaw will remove everything that isn't the bear. So the basic idea here is I'm attaching a custom chainsaw to the end of a robotic arm. So I should be able to move it anywhere that I want and cut whatever I want. The arm is a Tormach ZA6. Robot arms are super cool. They can move and rotate any way. The math behind this is called inverse kinematics, and for once, I don't have to solve it. Thank goodness. I'm sure you've seen a CNC machine run. You put a block of metal in, you hit a button, it goes to town, and you get a nice part when it's done. The only thing that a CNC machine knows how to do is follow instructions. To make the machine cut this part out, I have to tell it the specific moves that I needed to do so that the resulting shape is the part that I want. The motions that you tell a CNC machine to do, they're called tool paths because they're the path that the tool takes. When I want to make a part, I load it into special software that generates the instructions for the machine for me. Just like the CNC machine, the robot arm doesn't know anything. So I'm gonna have to write software to tell it specifically how to move so that the chainsaw cuts out the part that I want. These kinds of problems are hard because a computer doesn't see like a human sees. It doesn't have a concept of shape or space. It is completely infeasible to go through all these possibilities to find the best or even a really good cut. I'm going to start by focusing on just removing most of the material and not worrying too much about the shape of the part. I could cut down to the depth of the part that I want and then rotate around, changing my depth to whatever I need to just hit the part that I want. And then just repeat that all the way down the part. This would remove most of the material. I want to try my toolpaths, but I need a chainsaw that sticks out the absolute minimum distance. The further the saw sticks out, the more it will multiply any error in the positioning of the robot. But I can't just bolt a chainsaw to the side of the robot like this. These arms move in mysterious ways, and many of these movements will make the saw collide with the robot. All right, here's my design. It's built around a pole saw, which is basically a chainsaw on a stick. The number one concern for this design is keeping it as compact as possible so that it sticks out the minimum amount. The way my pole saw works is there's a shaft going into the back of it, and if you turn the shaft, that drives the blade. I'm driving the pole saw through this belt, which allows me to fold the motor up next to the pole saw and make it a lot more compact. It's almost an electric skateboard. This design should be able to avoid hitting the robot arm at least most of the time. I estimate from the speed that it was cutting that it would take about 10 hours to remove most of the log, and there's zero chance that that little chainsaw would survive continuous cutting for 10 hours. Now that we've established that converting the entire log to sawdust isn't a great strategy, I need to find a way to calculate a series of cuts that removes as much material as possible. Although this is where it gets tricky. If I'm only allowed to take slices off the model, then there'll be no way for me to get into these concave areas. What I really want is for the chainsaw to take scoops out of the part. So the best thing that I can do, come in and cut and then come back out, and then come in from another angle and meet the other cut, and then this will remove a sort of a wedge shape.